Kia ora koutou katoa. Welcome to our latest ArchNZ technical training. I'm Lennon Bedford. I'm the reality capture specialist for Global Survey here in New Zealand. And I'm very happy to welcome you to our latest event. Special welcome to international guests who have joined as part of our collaboration with Leica Geosystems on this webinar. And for those who are new to this, ArchNZ is a reality capture user group based here in New Zealand. The acronym stands for Autonomy and Reality Capture Hub New Zealand. We're a group of like-minded reality capture experts who are pushing the boundaries of what this technology can do. And we feel that we can be stronger together. So by sharing our ideas, we can raise the standard of the whole industry. I'm going to start with a short introduction on how automation in Leica Cyclone 3DR can contribute to a sustainable future. And then I have the pleasure of handing over to Yannick Stenger, who's based in France, and he's going to take us through a live demonstration and training. And then we're going to finish with a Q&A session at the end. If you have any questions, please pop them into the question area of the GoToWebinar platform, and we'll address them at the end. Right, so if you visit the Hexagon website, you'll see front and center this mission vision that Hexagon has of data that is fully and autonomously leveraged so that business, industry, and humanity can thrive sustainably. And I think this is a mantra that we, as a reality capture community, can really latch onto. As I think reality capture workflows have a really significant role in contributing to the sustainable future. How, you may ask? Well, today we have three very different use cases or applications of reality capture technology, all scenes captured here in New Zealand. So we have a road intersection first, just outside of Christchurch, captured with a Leica RTC 360 laser scanner. And we're going to show a virtual surveying workflow to create a traditional type topographical survey of this intersection, which could be used for, say, redesign purposes. Secondly, we're going to look at a point cloud captured with a UAV carried LiDAR unit and look at some analysis of line clearances, so vegetation to line clearances. And thirdly, we're going to look at a civil engineering project, a small subdivision here in Wellington, New Zealand. And we're going to show how point clouds and Cyclone 3DR can be used to measure and analyze volumes on an earthworks project. Now, all three of these use cases demonstrate efficiency. So reality capture technologies allow us to very quickly and completely capture these environments and reduce the amount of time on site and the number of repeat site visits required, and in general, lower our carbon footprint associated with the project. They all demonstrate safety. So the safety of people is an important part of sustainability. And so, removing people from live traffic lanes in the intersection example, or off steep and dangerous terrain in the case of this power line use case, or removing feet off the ground on a civil construction project where there's heavy machinery working. So they all make the workflows much safer for the people involved. And third but not least, quality is an important pillar of sustainability. So with the completeness and accuracy of this reality capture data and the automated workflows in Cyclone 3DR, we can proceed with these projects with so much more confidence that we're working with accurate data. And this allows us to make much more efficient use of materials, for example, and reduce the amount of waste associated with construction. So without further ado, I'm very happy to pass you over to Yannick, who's joined us very kindly from the evening in France. Over to you, Yannick. I'll allow you to introduce yourself.
Thank you very much, Lennon, for the introduction. It's really a pleasure for me today to participate and to contribute to the ERC-NZ and the Global Survey webinar. First time that we are delivering this kind of show with you, Lennon, so it's really a pleasure. So my name is Yannick Stenger. I'm the product manager for Cyclone 3DR. Cyclone 3DR software product to conduct reality capture workflows and to get deliverables from laser scanner data. And I've been in this position since I joined Hexagon almost 4 years ago. And as you can see, I don't have a survey background or a software development background. I really come from the construction industry and with a civil engineering background since the beginning of my journey. So let's start directly with what is on the menu for today and the 3 use cases that Lennon introduced. Really, my goal today is to show you why Cyclone 3DR is the most flexible reality capture solution to conduct multiple and diverse verification workflows, to monitor infrastructures, and also to keep them sustainable. I think this is really the purpose here. So let's start with the road intersection use case captured with a Leica RTC 360 scanner. So the first of the 3 live demo today. So welcome in Cyclone 3DR environment, if you are not familiar. So here I'm working on a point cloud, so that is from an LGS format. So LGS is the Leica Geosystems point cloud format, really convenient to host a large amount of points, so you can work with a very heavy data set. And immediately after the import of my point cloud, I always recommend to create a UCS. So here you have seen a 2-click UCS 2-point US creation. Even if later I decide to export and to export my deliverable in another coordinate system, but at least to work locally, it's convenient. And the next step, another tip that I recommend when I start a workflow is to create a limit box to focus on the area of interest. So here, this is the road intersection. And it's also a recommended step to convert the large LZH point cloud into Cyclone 3DR point cloud structure. So if you are familiar with Leica Geosystems environment, so in the CloudWorks menu, I'm going to convert the projects. So here, for virtual surveyor, so this is the feature that I will use. I don't have, it's not mandatory to keep the entirety of the point cloud. So here in this example, it really depends on the application, but to take, my measures, my points direct on the point cloud, a 50 million point cloud was more than enough. And then another important feature that I recommend to use for many applications, but in particular for a virtual surveyor, is to use the one-click point cloud classification. So here, the video is recorded, but what is important to know that this operation to classify the point cloud remains a one-click operation. So it might take a couple of hours to proceed, but it's a one-click operation and it's doable with a script. And then another strength of Cyclone 3DR is the capacity, in addition, and to finish the workflow after automatic tools, is to work with manual user-friendly tools to finish the workflow. So here I just change the colors to have a better understanding of the context. And if you are familiar with Cyclone 3DR manual tool, still manual, but very appreciated and very popular among our community, the capacity, like to clean point cloud, but just to select a group of points, clusters. It's very easy to rotate the scene, to define a fence, and just here assigning a new class. So in addition to the automatic classification, Cyclone 3DR is probably one of the single products in the market also to offer manual tools to deliver very refined deliverables. And here I have a very clean point cloud, I mean clean and rich with the information of the classification. And to pursue the workflow, I also recommend to explode. So it's another tip to explode the point cloud by class. It's a way to remove in a very fast way the points that I don't want. And so now I'm ready to work for my virtual superior operation. I don't have the noisy points, the moving objects. Also consider that so classification, but also the capacity to explode and to remerge a point cloud, removing some classes, is a feature that can be done in script. And now in Virtual Surveyor, so I just started let me just go back. So so to start the Virtual Surveyor, I don't have to do a selection. I can work on any kind of data, so mesh, point cloud, anything. So I just run Virtual Surveyor and I can work on my 3D environments. And first thing I would like to mention is the flexibility of the settings that we created, I mean, that we developed for our users. So for example, if you have to create a road intersection plan for specific municipality, you can load and prepare your own feature code standards. But if you have to do another job in another county, another city, another area, you can create different settings. So first thing to do is to prepare your settings, and then what you can see here, this is a new feature. So I mean, among the point selection tool, the pole center is a feature. You just have to click in the middle of a pole to detect the middle projected on the DTM. So this is really convenient, and I mean, which is nice. With this feature, you don't have to be accurate when you click on the pole. Automatically, it detects the middle points projected on the ground. And a funny story about this, I mean, this is a feedback that Lennon shared with us when we shared a beta version of Virtual Surveyor earlier this year. And I mean, just to show you that this is a good example of our capacity to integrate feedbacks from our community. And so thank you again, Lennon. That's a great tool. So as you can see, with my feature code, I can create points with feature code information. I can decide to show or to hide the text. I mean, you will see depending on the amount of information. And in addition to the points, I can also create polylines directly on my 3D environments. And also, I mean, in addition to my multi-lines for each vertex, for each point, I'm able also to extract a feature code. And I mean, this information at the end can be exported in proper layers in a DXF format, for example. So to extract here the edge of this road, so I can use multiple point selection. So I use pole center for the poles. Here I'm doing a demo with the ground point, so the point that is projected on DTM. Another solution also is to use to our lowest point capacity, which is really convenient for edges and to detect various borders here. So you can see also on the left part of the screen, I have a complete project that is filled. It's possible later to change, I mean, the colors, to assign to a new layer, to rename, to remove. There is also a copy-paste possibility that is not part of this demo. And another thing to do also, I mean, is to, I mean, it is possible to quit the workflow, to save your project, and to go back into your Virtual Surveyor project if you need to finish your job later. So again, this is another layer that I'm building for the for my fence here, and so you can see that also the classification representation here is really convenient to visualize each column of this fence. So very easy to have a feature code for each fence and to have a very detailed deliverable from it. So, I mean, my feeling is with point cloud and representation of Cyclone 3DR, it's even better than in real colors in this situation. So I mentioned that it's possible so yes, I'm just showing so the work in progress. So I extracted the poles, various lines. So I can quit the command. I can decide also to change the representation. Yes, so maybe a little bit a teaser for what's coming next year in Cyclone 3DR, but in addition to the point cloud representation, Virtual Surveyor will be a good workflow to use also the images from the laser scanner. Just a small teaser. And I decided to switch the point cloud representation from classification to intensity to identify the various road marks on the road. So here again, I can use points that are projected on the ground thanks to the ground point, or I can use also the lowest point in this situation. So pretty easy thanks to the intensity value, and there is a shortcut with the keyboard with the letter C to close the polyline in one click and to save a little bit of time. And so that was for the example of the arrows, and then for this triangle road sign, also very fast to extract with the shortcut that we have in Cyclone 3DR. So I think my my extraction is almost done. Maybe okay, let's see a final extraction of furniture in the street. So really to highlight here that it's really up to, I mean, you can customize the settings to host as many and as various layers and kind of information as possible, depending on your customers, the final company or engineering that will use the deliverable. And then it can be, I mean, so I got this map that I can export to DXF as an example. Also, we have a direct export to AutoCAD and to BricsCAD. Hexagon BricsCAD is also a CAD product from Hexagon. So this is in BricsCAD. And here we are for the road intersection extraction, and with all the information and the feature code that you can also export to a CSV list. So back to, so I just want to summarize the workflow. So, I mean, I demonstrated a few tips that are really the automatic classification that can be done with a script. So with no user interaction is really convenient and I mean, ideal to prepare your data, and then to execute your virtual surveyor operation. So this is a feature that we released this year. And at the end, you can deliver to many applications, and 12D, I mean, is a CAD software application that can be also used to consume the deliverable from Cyclone 3DR. So Virtual Surveyor exposes various manual extraction feature. I would like also to highlight more automated ways to extract operations. And so we have a predefined script in Cyclone 3DR application, which is the curb extraction. So it's, I think, the most popular favorite script in Cyclone 3DR. So it's been part of Cyclone 3DR since the first release. I think this video is 4 years old, but still it's a very popular feature to extract edges. And I will say a word about this, but please note that with our very recent script engine, the curb extraction feature now is 20 times faster since April. So it's pretty easy to use, and now it's even faster. And also, Cyclone 3DR is an advanced solutions. There are multiple ways to extract information. So here I mean, you can see in this video the capacity to filter the data with the red colors, to filter the data with intensity. So with the inspection steps tool, the possibility to explode the data into clusters, and also to use various tools like line extraction to detect the center line of road marks in this situation. And so this video is from Alexander Solopov. So this is one of my Leica colleagues. He's a big fan of our software products, but also a very nice ambassador. So I really recommend. So this one is on our YouTube channel, and this one is from Alexander's. I really encourage you to subscribe to his Unsurveyed YouTube channel. He really delivers advanced and nice workflows for Cyclone 3DR, but in general for Leica Geosystems reality capture and software products. So that was, I mean, that was two different ways to also to have more automation, and you can find lots of information in his channel for virtual surveyor application. So that was already for the first use case. So let's see now the second use case. And now I really like this one. It's so for a power line, a power infrastructure network maintenance application. And so let's see this use case. So with the point cloud coming from an aerial LiDAR scan. So this is so data set that Lennon gave me, and I really had fun. So thank you, Lennon. So I will start this workflow with a DTM. Maybe not the most important part of what I would like to do for this workflow, but still, I think it's always good to test the DTM feature in Cyclone 3DR for an outdoor application. As you can see, it's pretty easy to use. Just, I mean, I kept the default parameters. I just adjusted the size of the grid by 1 meter. So this is basically the resolution of my surface model. And my terrain model now, you can see, I mean, so I mean, it's the time of computation is live here for the DTM. So it's very fast and very easy to process, even for reality capture beginners. Another step, another very important information that you can extract from an outdoor dataset and from a DTM are the control lines. And again, control lines is also a very simple feature to use. So based on the DTM, so I kept my parameters. I already extracted control lines. It's automatic, and I mean it's very fast to extract. Just adjusting some parameters to have the good step for my final deliverable. But here I'm satisfied. So really, I would like to highlight, I mean, DTM control lines, very easy to proceed and a good way to understand the context. So let's get back to the point cloud. And here, so you can see I have electric lines, and I would like to do a clearance verification. So first of all, I will use the favorite script that we have. So it's part of the product for line extraction. So I need my point cloud. I changed the representation just for the purpose of the visualization. So this is a predefined script. Up to you if you want to adjust some parameter. You can see just to see one tip. If you need to go into this script, this is the only parameter that you may want to change. This is basically the step of the polylines that I will extract. One click to select my point cloud. One click to have a seed point to extract my polyline, and I'm just repeating the task for the six lines. And it's real time, efficient, and I mean reliable, So I mean that's a script that we are proud of, and you can see that the extraction of the 6 electric lines is so easy. To go further, maybe a couple of features that I would like to show. So first, you can see that I can change the visibility settings of my polylines, and I'm using some features like resampling polyline and also smoothing to get the most realistic lines from my first extraction. It's not, I would say, mandatory for this workflow, but it's a bonus way to get the most realistic electric lines. Okay, now that I have done this extraction, I'm focusing on the 2 bottom ones, the ones that are close to the vegetation. And so first, to create my 8-meter range area, I mean my 8-meter clearance area, I'm just creating a circle. So thanks to the modeling tool of Cyclone 3R at the beginning of the first polyline. So just pointing the center, a direction, and I'm repeating the task for the second line. And then we have extrude along a path to create a mesh, I mean an object along a path. So in this case, one of the 2 electric lines. And I can also close the objects. So here I extracted, I would say, so now I have a volume, and I want to check inside of this volume where are the vegetation, the trees that impact my clearance control. Before that, I just have to merge the two volumes, and for that we have another Boolean operation script, and it's also very fast to use it. So just selecting the 2 meshes, and I choose the strategy to merge the 2 volumes together. Okay, so now I'm ready to do the clearance verification with Python code, and here I will just make a pause. So you're going to see in 20 seconds the results of a script that I will describe after the demo, to really show you that you can create your script to save time and to get robust results for your repetitive tasks. Sorry. Okay, we're almost there. So I created this JavaScript file. I just have to connect, and I'm playing it. So what I'm doing, so it takes 2 seconds to keep only the points that are inside my volume, and for each of the, I mean, the support of the point cloud is splitted in clusters, and for each cluster, I was able to get a coordinate label XYZ, XY in this case, but I could add also the altitude. And everything happened in 5 seconds with the script. So this is what is magic in scripts. And just to show you a piece of what you can do in scripts, but you can even do more. Here, what I'm doing is a creation of a customized report chapter. And in this report chapter, I will have all the coordinate information for each of the clusters. And I can also decide to create various view sets to enrich my reports. And the purpose is to get, in this case, a PDF report that I can share to my customer, to the owner of my electric network. And this reporting part, I mean, the creation of a report chapter, the collection of view sets, and also the fact to gather all the values to PDF or to CSV can be also done in script. But here I'm showing this to you in the Cyclone 3R user interface, and just it's pretty easy to add the view set I created. You can customize yourself, I mean, the background, the scale, and etc. Another way to deliver this information to the end user is to use ortho images. And this is what I'm going to do here. So using the extract ortho image. So I have my top view representation with my clusters, the XY labels for each cluster. And then I just have to define an area of interest. There are parameters to adjust the number of pixels, the size, the background. You can load this kind of settings as well. I mean, you can save and load your own settings. And so in addition to the PDF or CSV exports, another kind of deliverable that is really useful for this application is to get an ortho image with all the labels and so the X and Y coordinates of each cluster. And a final tip, another way also to understand the context here. So I'm selecting one polyline, and from it, I'm creating a slice along this polyline. And what I would like to do is to review my vegetation clearance along this path. So I created this slice. I can also edit so I'm just renaming it. And I can also edit its depth and also the step, because it will be possible for me to visualize along this slide, and it's with the recent small improvements that we released, it's really convenient. So I'm selecting the slice. I use the log view feature. So it's a tip to block the view and to lock it along this slice, and using the Control plus Scroll shortcut, just maintaining the selection of the limit slice, I can go along my axis, my path, and I can visualize and see where are the issues, and then I can create more use sets. I could also add and keep some label information to make, I mean, my report even more complete. And then I generated this PDF, and coordinates can be also exported to CSV as well. So a short summary of the workflow. DTM, control lines, for me, those are basic tools for survey outdoor application of Cyclone 3DR. Very easy to use, easy to understand the reality, and it will be used again in the next workflow. Then for this advanced extraction, and I did a kind of clash detection operation that I'm going to describe in detail. And finally, I was able to export in various ways the information and where are the clusters, where are the locations of the impact of the trees with this electric line. So really convenient for the maintenance of power lines. So I can export to ortho image, but also I can create PDF reports, CSV table. So let's jump into the clash detection script that I created. Here, my goal is to show you that even someone who is not a software developer or who doesn't have computer skills can do very nice stuff. And this is the guy I am. So we have, and I will point to this page again at the end. We have a very nice documentation. It is online, it is public, so describing the API of Cyclone 3DR scripting. And so this is where you can find all the information. Here, so to start this piece of script, I used this iCloud.separatePoly function. So everything is described in the API documentation with examples. What are the inputs? What kind of outputs are returned from this function? So my goal here is to split and to detect the points that are inside the clearance area, So to split the point cloud into parts. So with a mesh as a reference. So here, this is this is a function that I will execute at the end of my script. So I picked from the documentation this existing function, and I just have to set a name for my output, to add it to the document, the 3DR projects, and okay, I just want to keep, but to hide my input mesh and my input point cloud. So this is the first step of the clash detection script. And then the next step, I want to create clusters from it. So this is the explode cloud, the explode iCloud.explode here. So this is a function that I found in the documentation, and I just have to to have of course a cloud as an input, and then some parameters like the distance between two clusters, how many, the maximum number of clusters. I did just one test, but 100 was good enough for this use case, and also a way to disable information. Those are the number of points I want to filter. If I have a cluster with only 100 points, I know that those are probably noisy points, so I don't want to keep them. So this is a way, here, this function, to create an array, a group of point clouds, so many clusters. And then last step of this script is to extract for each cluster the label, the X and Y coordinates of the centroid of each cluster. So the get bounding box feature is exposed in the script API. Actually, this is not a feature that is part of Cyclone3DR user interface, but you can get this conceptual object for any kind of object in Cyclone3DR thanks to scripting. And then it's a basic mathematical operation to get the centroid. And so this is the extraction part of the centroid. And then here I'm building labels. And for each labels, so this is a small table with the X and Y information of each centroid. So this function that I created, creation of bound box, is applied on a single cluster, and this function get centroid that I created is just a loop that I created to cover all the clusters and get the information for everything. And so then at the end, just okay, I'm selecting the visible point cloud, the visible mesh, and I execute the separation to keep only what is inside the current verification. Okay, it's faster to show it, to see it in the video than to speak. So this is really the benefit of script. And what I want to highlight here, for example, in this step, so maybe you remember 2 slides back. So from this operation, also there is an output that I don't want. This is, the main point cloud. The lines I don't want. I'm not interested. I'm just interested in the clusters of the vegetation. Okay, just to show you that here I didn't build the perfect script. That was not the purpose. My purpose is to save time when I repeat tasks. So okay, I did a disk line to just hide, to remove the biggest point cloud before the extrusion of all the centroids and the coordinates. So a software developer, someone with computer science skills could do better. But really, here I want to point out that you don't have to deliver the perfect script, and it can be a tool that you can be familiar with, that you can reuse for your tasks. And for me, that was more than okay to get my deliverable. And if I have to do it, maybe it will be okay. I know I created the script, and maybe I can also add instructions in my script as well, if one of my colleagues wants to use it. Okay, and let's jump into the final use case and the monitoring of a civil construction site. So this is another data set that Lennon shared with me from photogrammetry. And again, I'm starting this workflow with a DTM. So just having an overview of this point cloud. But before executing a DTM, what I'm doing is a classification. So we have 4 models: outdoor, generic, indoor, generic indoor construction sites, and a heavy construction for trained with UAV dataset. So this is the one that I'm using. And here, using the capacity to explode a point cloud by class, it's an easy way for me to remove parts I don't want, like buildings, vehicles, for example, and to keep only the natural components of this point cloud, and to be able later in my DTM to use, I would say, more advanced parameters. It's in a way to get the most refined DTM. This is a way. I could also use meshing features, but this one, I think it's a modern way and an easy way to get a refined DTM with classification. And you don't have to jump into too complex parameters in meshing, but it's a very good way. So I can, I would say, be optimistic in my slope parameter here to get the refined DTM and a realistic one. So here I'm going to point on this area. So this is the edge, I mean the edge of the terrain that is maintained in my DTM operation. Thanks, and I use the classification to get this level of detail. So I imported the design of my work site. So I don't know, I didn't like it in green, so I decided to change it to a transparent blue one, but just to show you that any kind of object you can play with the representation for your own convenience. And just now I'm going to do a cut and fill operation, but prior to this operation, I would like to just have a contour. I'm extracting a contour of my DTM and to really focus on the area of interest. And so I can use Cyclone 3D meshing advanced tool to keep only the area of interest. And I will keep this part of the design model, my mesh. So it's going fast. Cut and fill, you can see it's going very fast. I just select the design, the measured model, and it's a one-click operation to get the over/under volumes. And that's it. That's it. And a report, and I have a report that is automatically filled. I will come back into that. But before watching the reports, I can also bring more context with the creation of a color map. So using the comparison between the two meshes. And here we have predefined color gradients. So I can really visualize the over/under parts between the situation of the work site, so my DTM, and the target, the design target. So this is a CAD model. And I can show again the volumes, and I can update my view sets, and now jump into the report editor. And so this is typical for Cyclone 3DR analysis features. Automatically, the report chapters are filled, and then you can customize. You can change your own template as well, but it's very fast. Also would like to show you graded inspection. This is another way to deliver, I would say, information and values from an inspection. So it works on inspected surfaces, like this colorized, like this color map. I'm just changing some parameters. So on a grid, I can get the difference, the deviation between the reality, so the DTM, and the CAD. And so this is I define the step, I define, so those are values in centimeters, but this is another way to understand and the context, and okay, here I have 2 meters to fill, etc. Just before, and this this grid can be also exported to the XF and with the colors, and also it can be sent to AutoCAD. And the final part of this use case is the creation of a raster. It can work on a point cloud, or it can work on a mesh. So this this is another one that was really pushed by Lennon, and I'm really happy to say that we released on our GitHub this script last 3 weeks ago. So if you are a Cyclone 3DR user, it's public, it's free, and now on GitHub. And so the purpose is to get a raster to a CSV format or to an ASCII format on a point cloud, off a point cloud. So with the altitude information, and we have various options, including the lowest point or the highest point. And just I prepared an origin and axis for the purpose of the demo, but it's not mandatory. And from this raster script now on GitHub, you can see that I extracted this CSV spreadsheet with the altitude of my terrain, arranged in columns and rows to have a raster information. So let me summarize this final use case. DTM, very important for many outdoor workflows, and advanced DTM, multiple ways. I think we have a very good one on our YouTube channel that I encourage you to watch. And for this one, I used the classification to clean very easily the data, the noisy points, or at least the non-natural ones, to get the most refined model in a very easy way. And then the content field operation, very easy, very fast as well. I mean, the video was fast, but it was, it was a real-time extraction. The difference of calculation between the two surfaces, it's a very fast operation in Cyclone 3DR. And then another way to also, to get the most of your reality capture data, it's now the new raster export script that is online on GitHub. So before concluding and eventually replying various questions, I would like just to remind you the updates about scripting. So I mentioned this earlier, that so in the April release, we delivered a new engine. So maybe this is not a lot for you, users of our products, but that was a big effort to modernize it. And one of the very nice benefits, this is the acceleration. So it really depends. The comparison with before depends on how the script is built. But as an example, the script of the curve extraction, it is 20 times faster. So I encourage you to test it. And the documentation is modernized, easy to use. So and you find all these kind of links. Maybe we can share them with you later after the webinar. But on the official site of Cyclone 3DR, you can find also this documentation. There is a link from the Help Documentation Center, so easy to find. More recently, we have been very active on socials. So here I just don't want to talk only about my LinkedIn posts, but you can have a look and you will find very interesting information. We released a new YouTube playlist dedicated to scripting. So there are nice use cases. So again, have a look, please, if you are interested. The GitHub page that is free and public was enriched with the raster, but also a nurse embedment script that we created earlier this year. And you can find also some articles, also other use cases and latest updates. So, and also an interview with also a partner from Canada that created nice scripts for his customers in North America. So please have a look. And also about what's coming next for the scripting ecosystem. This is a very cool improvement. It will be possible to create your own dialogue from scripts. So maybe if you are behind the code, that is not what is important for you, but for the people, for the end users that will use the scripts, for your colleagues, it will be much more user friendly. And also, I mean, for the ones who will do the code, it's pretty easy to do. It's a new feature. It's very well documented. There are many various features that you can add, images, various choices, tooltips. I created this one myself. Again, I'm not a software developer, so it works very nicely. So that's coming for the January release of Cyclone 3DR. And not only about scripting, but in general, I'm taking the opportunity to announce, I would say, the major features of the coming release in January. So part of the general improvements of the product, we really want to boost the experience, the reality capture experience in Cyclone 3DR. So yes, definitely stay tuned for the new experience for image visualization. Cyclone 3DR history comes from the point cloud, but more and more reality capture data is not only point clouds, but also images. And so it will be also possible to draw images for virtual surveyor for extraction, not only on point clouds, but also on images, with also the capacity to have multiple 3D screens that is already released in Cyclone 3DR, but with the synchronization of the camera. So it's a very awesome features. I mean, and for advanced users with multiple screens, it will be very comfortable. Stereo rendering more nice to have, but also more auto classification. So this is really the strength of our developments. So 2 years ago, we released automatic classification, but we have the capacity to add more and more models. So we released 2 more at the beginning of the year. And in January, we'll have 2 more models, one dedicated to the road. So trained with MMS datasets, but still convenient and good for RTC360, for example. And also a specific one to filter people for BLK, dynamic BLK. So this is a screenshot of the work in progress of, it will be, the kind of results that you will expect from the dataset that I used for the first demo. And in addition to the generic improvements for 3DR, now I would like to have a focus on the various industry features. So for the survey application, we have a big modernization of the experience to extract profile and to analyze them for road and tunnel applications. So a guided workflow to make it more user-friendly and also to get rid of some known issues of the feature. So a very modernized experience, and a very nice feature would be the capacity to import trajectories from Leica sensors like TRK, but also BLK. And for TRK, I mean, in addition to just the new object trajectory, that would be, I'm talking about, I don't know, like 10 new script functions. So it will be possible to do automated extraction of large data sets on LGS point clouds with scripts. So that's that will make this kind of workflow even more powerful. A quick word for the AEC industry. Sorry. So this is permanent improvement. So we are doing our best to make Cyclone 3DR more and more beam friendly. Progress monitoring that we released last year is improved with more detailed, more screenshots for each object in the reports. So progress monitoring, purpose of the feature is to create, to have a progress status report, not deviation analysis, but really to compare an IFC and a scan and to conduct the progress of a project, including classification information in this one as well. New visual notes, more for beginners, I would say, or reality capture, new users in the community, and various updates for Scan to Plan. And a final word about a new edition, and this is, I think, the first time I'm talking about this in public. We will have a new edition, a plant in Cyclone 3DR coming in January. So this edition replaces the tank inspection module, so but it will include much more at a very attractive price, so including tank, some canning analysis tools, automatic classification, and scan to pipe, the first big feature of the plant edition. And so you can expect much more new features in the next couple of years for the plant edition. And here is just a teaser of the work in progress. Thank you very much for your attention. It was a pleasure. So I don't know. Let's get back to you, Lennon.
Thanks very much, Yannick. That was fantastic. And thanks, so much for all the work you've put into preparing that. I thought it was really cool to see a combination of automated single-click operations in 3DR, but also, the flexibility there is into creating your own scripts and see such different data sets. So that's one of the strengths of 3DR, I think, is how agnostic it is to point cloud formats. It doesn't matter if it comes from a photogrammetry data set or a Leica sensor. It all works in 3DR just as well. I have a few questions that have come in. And if anyone else has questions, feel free to put them in the chat or the question and answer area. One question from Graham, from Yannick, is it when you're in Virtual Surveyor, is it possible to utilize any of the scripting functionality inside the Virtual Surveyor? So I guess a good example might be that curve script.
Yes, for now, it's complementary. So it's not possible to have these automatic extraction tools, scripting or other tools in the Virtual Surveyor module. It's a request, and I'm familiar with this one. So that's part of the known improvements for Virtual Surveyor. But I mean, it's totally possible to combine both. Really, the benefit of the Virtual Surveyor tool that is, I must confess, more manual, is the capacity to immediately sort every extraction in various layers and to manage your settings. So not yet possible, but thank you for, pointing again this request. Taking a note.
Okay, cool. Something for the future. Another question came in from a 12D user, which is a popular surveying and engineering package in New Zealand, and something I can answer actually is a workflow for turning that line work into a tin in 12D. What's the workflow for that? So what you could do is take the line work that Yannick has created in the Virtual Surveyor and also combine that maybe with the extraction of a points on grid to get some spot heights over the remaining areas. And then in 3DR, you can create what's called a constrained mesh, which is essentially a top-down tin using the break lines and the points on grid. And then you can send that mesh to 12D via a simple DXF file would be the easiest way, or an XML file even. So there's definitely a workflow there. The alternative is to take the line work and point on grid into 12D as a DXF and then create a tin within 12D. So both workflows. Another one, Yannick, you mentioned scan to pipe. Can you tell us any more about that? What's coming in the next version?
A little bit too early to show you. I have a very work in progress, nice videos, but a little bit too early to show them publicly.
But essentially, it's some of the functionality from model, is it? From Cyclone model?
So yes, so Cyclone model, probably lots of you are familiar with Cyclone model. So this is another software product in our portfolio. It's not really maintained anymore. And I would say the long-term plan is to have a Cyclone model into Cyclone 3DR ecosystem, because Cyclone 3DR is permanently improved. Mentioned the capacity to work on images, for example, multiple screens. So that's the long-term plan to replace or to host Cyclone model features. So Scan2Pipe, it's not officially the replacement of Cyclone model. I mean, we won't reach the feature parity. Let's be clear. But with this plant edition, Scan2Pipe will be possible. So to extract straight segments, elbows, and reducers. And my wish list is very long. So more assets and also more and more automations. We are working with AI groups within Hexagon also to do things with less and less human interaction. Did I reply to the question?
Yeah, I think so. So there'll be essentially fitting tools similar to what are in CloudWorks and model at the moment.
Tools to extract based on a few clicks straight segments, to connect automatically elbows, to create automatically reducers, and more assets, more connections. That's short-term plans for the next release, the next +1.
Great, fantastic.
And
one more question.
Yes, this plant edition I didn't mention will be part of Pro. So automatically, users who are on them, who has a valid maintenance, a valid subscription with a Pro edition, will benefit automatically for all the features of Plant edition.
Great. One user asked if the datasets can be shared. I can absolutely make them available, so just get in touch.
Okay.
And then maybe time for one more question. We're running out of time. You mentioned trajectories. So what is the benefit of bringing the trajectories into 3DR? How will they be used?
So trajectories will be a new object, but I would say, visually very similar to polylines. And so without any conversion, those trajectories will be available. So in addition to the conversion of an LGS, in addition to the point cloud and the images, you will have the trajectories as well. And so it's possible to create a limit slice, like I did with the polyline from it. And so we will have also the timestamp information to clean the data and focus on our area of interest, to remove the points that are farther than 10 meters from the axis. And also, I mean, another great improvement, this trajectory will be compatible with the new profile extraction, profile analysis workflow.
Okay, so lots of benefits in having it there. I guess it'll help with
many script functions as well, so to process data. Okay,
fantastic. Right, thank you, Yannick. Okay, just to finish off, I just wanted, well, actually really excited to announce our first ever in-person ArchNZ user conference in New Zealand, in Auckland next March, Friday the 22nd. We've basically 90% through locking down the program, and we've got a really fantastic lineup of speakers, all sourced from our ArchNZ community. So I highly recommend joining. We've designed it in a way that those based out of Auckland will be able to fly in and out for the day, and we'll host it at the Sedema at the Auckland airport to make it nice and easy logistically. So yeah, please register your interest using the link there, ArchNZ on our website. As always, yeah, please get in touch, send us your feedback, let us know how you enjoyed the session, or if there's anything we can do to improve. If you would like to present something that you've been working on recently and you think it could benefit the wider group, feel free to get in touch. We do have the LinkedIn group. Feel free to share your work with them there. And with that, thanks again, Yannick, and thanks to all of you who have joined today.
Thank you.
See you next time.